Hello friends, welcome to Algorite. Uh, Today in this session we are again going to discuss about sorting algorithms. In my last session we talked about bubble sort, the logic behind the bubble sort, how it's being implemented, and we have also seen a coding session using Java. So in this session I'm going to cover insertion sort. So let's go ahead with that. Insertion sort is an algorithm that sorts a list one element at a time, pretty similar to bubble sort. And with each iteration, it takes the next element we are trying to sort and adds it in the proper location. Which means um, basically, if you look at the figure or the picture, in this we are trying to sort an unsorted array of elements 85, 12, 59, 45, 72, and 51, and we want to put all the elements in an increasing order, and we start beginning with 12, and we look the predecessor or the previous element, which is 85, and if it is the predecessor is greater than the current element, then we move the predecessor to the right location. um, so the idea behind it is you iterate through the array from the first element to the last element, and compare the current element. And if the current element is smaller than the predecessor, then you need to compare it to the elements before. Uh, Otherwise, you move the greater elements one position up to make space for the swapped element. So it's pretty much similar to the bubble sort, but in a way, like there are some variations. Like in bubble sort, you compare the adjacent elements always, and then keep doing it till the end of the array for each element, so it is off and square. But here, you're trying to check with its predecessors, and then current, uh, moving the element which is in a greater value to the right position in the array makes it again an off and square and complexity. So when it goes to space complexity, the space complexity is again of one, because we are dealing with the same array. There is no auxiliary space extra added to this, and that's where it's an optimal space complexity wise algorithm. Um, but the time complexity is pretty expensive in this case. So let's go ahead and try to implement this algorithm using Java programming language, as we have seen earlier, and then we can take it from there. Okay. Now, um, let's say I am just using the same class, which is the sorting class, where I have implemented bubble sort. So I'm going to use the same sort class, and then I'm going to create another method here called insertion sort, which is which also returns an integer array, which is a sorted array of integers. So I would say like unsorted for this as well. And then now in the insertion sort, the basic idea is you need to move the elements that are greater than the current element to one position before the current position, right? So for that, what we're gonna do is the approach is like first we will calculate the length of the array, which is n. Let's say we get the length of the array as n. It's an integer, basically assuming that the array is bounded by integers. So in the I from we begin from the element with index I equals to 1, because we wanted to find the predecessor. We always go with uh, the second element in the array. So I is equal to 1 and I is less than n I plus plus. And now we're gonna find the key. The key element is your current element, which is unsorted of I. You get that. Now, once you got the key element, we need to keep track of the predecessor. So we just say that J is like to keep track of predecessor. I'm just adding some comments as well to make sure it's clear and understandable. Now we go into a loop. basically we go into while loop because we already have the index declared, that is the predecessor. So we say that while j is greater than or equal to 0, which means it is not the first, you're not accessing the first element in the array, and then your unsorted of j, the predecessor is greater than your key, right? So if the predecessor is greater than the key, then unsorted of j plus 1, which means the current element that you have is nothing but your predecessor. So you are just actually using your predecessor or moving your predecessor into the next element, and then you decrement j by 1, so j minus 9. So, and then at the end, you need to map the current element or the next element of your predecessor to the current element to make sure that you're putting that in the right place. So yeah, so now you're gonna return your unsorted array pretty much, because it gets sorted by this time, right? So this is what we're doing. So let's run this code. So I have written some code here already. I'm just reusing the same thing which I have used for bubble sort. It's an array of unsorted integers, and then we are printing the unsorted array first, and then we are invoking the insertion sort method using this insertion object, which is created from the sorting class. And then I'm just printing the sorted array after insertion sort is executed. So let's run and check it out. Okay. So if you see here, the unsorted array is the given array, and then the sorted array after insertion sort is sorted in ascending order properly. Okay, cool. So this is the end of this session about insertion sort, and I will cover other sorting algorithms in my future sessions. If you have any feedback or comments, please put it in the comment section in the video if you like it. Thank you.